Hey, I'm Wasibuddin. This is my mouse. Sadly, it's broken. So, what would you do if you were me? You would buy a new mouse, right? Well, I'm different. This is the money that I have currently with me. So, what I am going to do is that should I buy a new mouse? Nah. I'm sad that my mouse is broken, but at the same time, I'm craving some yummy pizzas. So, what I am going to do is that I am going to create a virtual AI mouse for myself and order a pizza with that money. So, in this video, I am going to teach you how you can create your own virtual AI mouse. So, when your mouse is broken, you can treat yourself a pizza just like me. So, without any further ado, let me order my pizza and move on to the tutorial. We will start by doing the first basic thing we need to do for creating our virtual AI mouse, that is setting up our webcam. At first, we will install the OpenCV module using the command pip install opencv-contrib-python. I will not install it as I have it pre-installed in my system already. Now let's import OpenCV using import cv2. Next, we will create a video capture object named cap and pass in the argument 1. I have set it to 1 as I am using an external webcam. You can set it to 0 if you are using your system's inbuilt webcam. After creating the video capture object, we will set its width and height to 640 and 480 respectively. Here 3 and 4 represents the width and height of the video capture object. Next, I will create a while loop and set it to true. Now I will read in the feed from my webcam frame by frame and store it in img variable. Here success stores a boolean value true or false, representing if the feed from our webcam is being reading properly or not. Next, we will flip the frame horizontally using cv2.flip. Now we will display the stored frame using cv2.imshow, where at first we will pass in the window name. Let's name it camera feed. You can give any name you like. Then we will pass in the img variable. At last, we will set a delay using cv2.waitKey. As my webcam setup is complete, let's run the code. As the feed from a webcam is being read properly, we can move on to the next step. For hand tracking, we will use the module Cvzone. You can install it using the command pip install Cvzone. Now from cvzone.handTracking module, we have to import hand detector. Then we will create a hand detector object named detector and set the parameters detection confidence to 0.9 and max hands equals to 1. Now using the method detector.findHands, we will extract and store all the information regarding our hand, like our hand landmarks, if it is our right hand or left hand in hand variable, and the processed image in img variable. Here I have set flip type equals to false, as we have already flipped the frame horizontally using cv2.flip. Let's see if our hand is being tracked properly or not. Now as my hand is being tracked properly, we can move on to the next step, that is setting up the mouse features. But at first we will understand the hand landmarks. This image shows all of the 20 landmarks of our hand with their index value. For example, our wrist is denoted with the index value 0 and the tip of our thumb is denoted with the index value 4. For controlling the movement of the mouse, I will use the tip of my index finger, which is represented by the index value 8. So let's get back to coding. Now if our hand is present in the frame, we will store all the 20 landmarks of our hand in the variable ln list. Then from element list, we will use the 8 landmark from which we will extract the x and y coordinates of the tip of our index finger. Next, I will draw a circle using the x and y coordinates to show the tip of my index finger using the method cv2.circle. Now let's run the code. You can see that the tip of my index finger is shown in yellow. Now I will integrate my hand movements with the movement of my mouse. For integrating the mouse, I will use the package mouse. I am using the package mouse instead of PyRTG as PyRTG is a bit sluggish. You can install the mouse module using pip install mouse. Now let's import mouse. Next, I will find the width and height of my screen. There are various ways to find it, but I will recommend you to do it using the method that I'm gonna show you. Let me show it to you by opening a new Python file. At first, we will import the module mouse. Next, I will create a while loop and set it to true, and then print our mouse position using the method mouse.getPosition. Now if I run the code, in the terminal you can see that I am getting my current mouse position. Now if I take my mouse at the bottom right corner of the screen, I will get my screen width and height as 1535 by 863, which ultimately means it's 1536 by 864. So now why I am using this method to get my screen size where I could use any other module's inbuilt function for this purpose. Let me show you the reason. Now I will find my device screen size using the module PyRTG. Let me write the code first. If I run the code, you can see PyRTG shows my screen size is 1920 by 1080. On the other hand, the mouse module detects my screen size as 1536 and 864. So if I use the screen size that I have got using PyRTG, the mouse module will not behave as expected. As two modules tells us a different range, it's best to use the method that I have shown to you to prevent any intermodular errors. Now as I have cleared up things to you, we can move forward on to the tutorial. Now I will convert the coordinates of the tip of my index finger from the range of my webcam's width and height to the screen size of my device. I can do it using a method from the NumPy module. You can install NumPy using the command pip install NumPy. Let's import NumPy as MP. Now I will convert the ranges using the method mp.inter, where at first I will pass in the x coordinate, then a tuple consisting of 0 and width of my webcam, followed by a tuple consisting of 0 and width of my screen. I will do the same thing for the y coordinate of my index finger. Now I will pass in the new xy coordinates, which are converted with respect to my screen size in mouse.move method to map the controls of my hand to my mouse movement. Now let's run the code and see if it works. If I take my hand to the left, the mouse goes to the left. If I take my hand to the right, the mouse goes to the right. So our mouse is working properly. But there are some problems that we need to solve. Notice here, if I take my hand to the right edge of the screen, the hand detection jitters and it goes away. Same case happens if I take my hand to the bottom of the screen. I cannot take my mouse to the bottom of my screen and my hand detection disappears. So we need to solve this problem.
At first, let me explain you how can we solve the problem. Then we will do the coding part. In this image, you can see my webcam display window in black, where width and height of my webcam is 640 and 480 respectively. Now the problem we are facing is that suppose the mouse cursor is my hand. If I take my mouse cursor to the edge our hand tracking jitters. To solve this problem, we will reduce the frame size. Let's reduce the frame size by 100 units. That means my new starting point for controlling the mouse movement in my webcam's display window will be the point 100 by 100 instead of the point 0 by 0. And the end point of my display window will be 540 by 380 instead of the point 640 by 480. Now if I take my hand at the point 100 by 100 of my display window, the mouse cursor will move to the point 0 by 0 of my actual screen. And again, if I move my hand to the right down corner point, 540 by 380, this point will represent 1536 by 864 point of my screen. Basically, previously the miniature version of my screen was represented by the display window of my webcam, which is totally black. Now we have shrink it, which newly represents the new miniature version of the screen. Now if I take my hand at the edge of this purple window, my hand will not jitter as my hand is not at the edge corner of the display window and I am only using a portion of the display window to navigate my mouse movements. As now you have clearly understood the topic, we can now move on to the coding part.
We will now have to solve this problem to make our virtual AI mouse more smooth and precise. At first, I will store the frame reduction value in a variable. Let's name it frame R and set it to 100. Next, I will draw a rectangle in my display window where the starting coordinates will be framer by framer, that is 100 by 100, and width and height of the rectangle will be my cam's width subtracted by framer and my cam's height subtracted by framer. Next, we need to make one last change in mp.interp. Here I will change the value 0 to framer as our starting point is 100 and cam width to cam width minus framer. Similarly, I will change it for the y coordinate. So this should solve our jittering problem. Let's run the code and check if it works or not. Now if I move to the top edge of the purple rectangle in my display window, you can see that the mouse moves to the top edge of my screen, and if I take it to the right edge, it goes to the right corner edge of my screen. So now my hand is not jittering at all. So our jittering problem is solved, but the part for moving the mouse is not complete. I want to move the mouse only if my index finger is open and rest of my fingers are closed. To code this, I need to know how many of my fingers are actually opened. To find this, I will use the method detector.fingersup, which will return me an array of 5 numbers consisting of zeros and ones. Here in the array, 1 represents the fingers that are open and 0 represents the fingers that are closed. Let's print fingers to check if the array stores all ones if I keep my hand open and all zeros if I keep my hand closed. If I open my hand, you can see that the first number in the array is 0 instead of 1, telling me that my thumb finger is closed. And if I close all of my fingers, it shows that all of my fingers are closed except my thumb finger. So why the output is like this? Let me explain it to you. See this image right here, it exactly shows the output we should be expecting. If we keep our hand open, all the numbers in the array should be 1, and if we keep our hand closed, all the numbers in the array should be 0. Now notice this line of the code at the very beginning, we flipped our frame horizontally, and in the next line, we have set flip type equals to false, as we have already flipped it once. So what problem does flipping the frame horizontally creates? The finger up method interprets our right hand as left hand and counts the number of fingers up using the algorithm for the left hand, though we are passing the inputs for our right hand. So the result for our fingers up method shows like this. So the output that was printed before was not wrong. Here only for the finger thumb, 0 indicates that our thumb finger is open, and 1 represents our thumb finger is closed. As we have understood the reason for our output, now back to the coding part. If my index finger is open, middle finger is closed, and my thumb is also closed, then we will move the mouse. Now I will cut this part of the code and place it within the if statement. Here I am passing the condition for my thumb and middle finger to be closed because I will use those fingers to set other features of my mouse.
Now let's run the code and see if the left click function of our mouse works properly or not.
Now if I open my index finger, the mouse starts moving. If I close my index finger, the mouse stops moving. As our mouse movement is completely done, we can now set the rest of the features of our virtual AI mouse. Now I will set the left click function of my mouse. I want to click the left button of my mouse if both of my index and middle fingers are open and the fingertips of these two fingers are close to each other. So let's write the code for this. At first, I will extract the hand landmarks for my middle finger using the index number 12. Now if my index finger is open, middle finger is open, and my thumb is closed, and if the distance between the tip of my index finger and middle finger is less than 25, then the left button of my mouse will be clicked using the method mouse.click. But if I run the code, a small bug will appear. Can you guess what the bug is? When the distance between the tip of my index and middle finger is less than 25, I want the mouse to give a single click. But here, instead of giving a single click, the mouse will give multiple clicks because between each click, I have not set a delay here, which will give me time to move my two fingers away from each other to prevent multiple clicks. So how can we solve this problem? I know what you're thinking. You're thinking of using the time module, but sadly we cannot use it directly because we are reading in the feed from our webcam in a continuous loop. So using time.sleep method for some seconds will freeze our loop and our webcam feed will be stuck. So to add some interval while keeping the frame rate constant, we will have to use threading. Threading will allow us to run multiple things parallelly at once. So now let's import threading and time module. Now we will create a thread named left-click thread, where in the target we will pass in the function we want to run parallelly with the loop. Now let's create that function. But at first let me create a global variable named lDelay and set it to 0, whose value will turn 1 if I click the left button and will not turn to 0 until that interval between clicks is completed. Let me at first modify my code here. If left delay equals to 0, then we can click the left button of our mouse and the value of lDelay will be set to 1. We will also start the threading using left click thread.start. But here we did not pass any function in the threading's target. Let's create that function. Let's name that function left click delay. At first, we will bring in the variables lDelay and thread left-click thread inside the scope of the function by declaring them as global variables. Next, we will set the interval using time.sleep. Let's set it to 1. Then after 1 second, the value of lDelay will again be set to 0. And we can again click the left key button of our mouse. At last, we have to reset the thread again here. And we have to pass in the name of the function we have created in threads target in both places. Now let's run the code and see if the left click function of our mouse works properly or not. Here I have opened up a website that will allow me to test my mouse clicks. Now if I open my middle finger, the mouse will stop moving. And if I bring both the tips of my finger close to each other, left button of the mouse will be clicked. In the website, we can see that left button of the mouse is clicked. It means that our left click is working smoothly. As our left click is working fine, we can now set the right-click function of our mouse. For clicking the right button of our mouse, our hand posture will remain same. The only difference is that our little finger will remain open at the time of right click. So let's get into coding. Here I will edit the code of my left click a little bit. I will set an extra condition that our pinky will be closed along with L delay equals to 0 during our left click. Now for right click, I will copy the same thing as I did for the left click. Let me copy this code here and change if our little finger is open and change everything related to left to right. I will also copy the function and thread of the left click and make an identical one for the right click. Now as my changes for my right click is done, let's run the code and see if both of our clicks are working fine or not. Now at first I will test my left click. Click. My left click works perfectly fine. Now I will test my right click. Click. Right click works perfectly fine too.
As both of the left and right clicks are working fine, we can now build the scrolling function of our mouse.
I will control the scrolling feature using my pinky finger. To activate the scrolling feature, first I have to open my index and middle finger and keep them apart like I used to keep it before activating left click. Then I will open my thumb finger. If I bring the tip of my index and middle finger close to each other, keeping my pinky finger closed, down scrolling will be activated. If I do the same thing, keeping my pinky finger opened, upward scrolling will be activated. Now as I have explained you the controls, let's move on to the coding part. If my index, middle and thumb finger is open but my pinky is closed, and if the distance between the tip of my index and middle finger is less than 25, we will scroll the mouse downwards using the method mouse.wheel. Here I have set delta equals to -1 for downwards scrolling. We will do the same thing for upward scrolling. The only change we have to do in this case is that our little finger will be opened and the value of delta will be set to +1 for scrolling upwards. Now let's test the scrolling function that we have created. First I will set my hand posture, index finger open, middle finger open, thumb open. Now if I bring both the tips of my finger close to each other, downward scroll is activated. Now if I do the same thing, keeping my pinky open, upward scroll is activated. So our scrolling function is working as it was supposed to be. Now we can move on to create the final feature of our virtual AI mouse. Now we will make the most important function of the mouse, that is double click. Making it is very simple. The hand posture for double clicking our mouse is while our index finger is open. If we open our thumb finger, then the left button of the mouse will be clicked 2 times, resulting in double click. Now let's code it. If my index thumb finger is open and my middle and pinky finger is closed, we will click the left button 2 times using the method mouse.doubleclick. So finally, building our virtual AI mouse is completed at last. But wait a minute, we are forgetting something. Can you guess it? The double click feature has the same bug like the one we had during the left and right click. That means we have to add a time interval between each double click and thread it. You know how it works. So let me do it similarly like I have done for setting the left and right click of my mouse. Finally, at last, our AI virtual mouse is complete. Now we can move on to the demo part, combining all the features of our virtual AI mouse. Let's have some fun with it. Well, this is my YouTube channel. The first coolest thing you can do after creating a virtual AI mouse is that you can subscribe to my channel. It's completely free. Let me roam around my channel. Let me play the video Subway Surfers.
In this lockdown,
Let me pause the video. I can make it full screen by clicking double click. What else can we do? Let's check the comments. We have some decent comments here. Let's try upward scrolling. It looks like the pizza delivery man is here. I'm also done with the demo. That's what I call the perfect timing. Let me get my pizza and I will be back in a short bit. My pizza is here. It smells so good. It looks cheesy delicious too. Let me have a bite. Now that's what I call a true pizza. While I enjoy my pizza, you can enjoy the rest of my videos. That's it for today. See you next time.